Okay, so this video is about writing the formula of ionic compounds. Remember, ionic compounds typically contain a metal and a non-metal. Potassium sulfide would be an example. For ionic compounds, we can write two different types of formula. We can write the ionic formula or the chemical formula. It's important that you know the difference between the two. The ionic formula shows both the charges and ratios of ions in an ionic compound. For example, for potassium sulfide, the ionic formula is K plus 2S 2 minus. So it shows both the charges, so you've got a plus and a 2 minus, and also the ratio with the little number at the bottom right of one of the ions. We've also got the chemical formula, which for potassium sulfide would simply be K2S. So we're not showing the plus and minus charge, we're only showing by this little number to the bottom right of the symbol that there are 2 potassiums for every 1 sulfur. So hopefully in the next few examples I'm going to show you how we get these brackets and this number 2. In this video I'm assuming that you already know how to work out the charges of ions. Okay, example 1. Write the ionic formula and chemical formula for sodium bromide. So in the method that I'm going to use, first of all we're going to work out the charges on the ions, then we're going to work out the ionic formula, and then we're going to work out the chemical formula last. The chemical formula can sometimes just be known as the formula. So sodium bromide, the charges on the ions I expect you to be able to work out already using the periodic table. So sodium is 1 plus, it's in group 1. Bromine is in group 7. It's going to have a negative charge. Once we've got the charges on the ions, to work out the ionic formula, what we need to work out is how many of each type of ion we need to make the charges balance or cancel out to be neutral overall. Now, sodium has a charge of 1 plus. Bromide has a charge of 1 minus. Overall, these numbers balance out to make a value of 0. So for the ionic formula we actually just need 1 of each type of ion. The difference between what I've written here and the ionic formula is that in the ionic formula I need to make sure that I write these ions nice and close together to indicate that this is one substance. This is just my working out, I don't need that. Finally, to write the chemical formula, I just need to write this so that it doesn't show the charges. Now because I just needed 1 of each, it's just a 1-to-1 ratio. We don't write in ones in chemistry. So our chemical formula for sodium bromide is just NaBr. Example 2. Write the ionic formula and chemical formula for magnesium chloride. So again, I'm expecting that you should be able to work out the charges on a magnesium ion and a chloride ion. Magnesium is in group 2, it's going to be 2 plus. Chloride is in group 7, and it's going to be 1 minus. You don't have to put the 1, you could just put in a minus. Now that I've got the charges on the ions, to work out the ionic formula, I need to work out how many of each ion I need so that the overall charge balances out and equals 0. At the moment I've got 2 positive charges and only 1 minus charge. So I need another chloride ion to give me a total of 2 negatives. If I've got 1 magnesium and 2 chlorides, then I get an overall charge of 2 plus and 2 minus, which gives me a 0 overall. Now that I know that I need 2 chlorides for every 1 magnesium, I can write the ionic formula. Because there's only 1 magnesium, I just write it as it is where I've written the charge up here. But because I need 2 chlorides, I'm not going to write it out as I have in my working here. I'm going to use brackets and a small number outside the brackets to show that there are 2 of the chloride ions in the formula. So the 2 to the bottom right of the symbol for the element shows that there are 2 of that ion in the formula. The reason I need brackets is because I have not only got 2 chlorides, I've also got 2 minuses. So the brackets show that this 2 applies to the symbol for chlorine and to the negative charge. Now that I've got the ionic formula, it's quite simple to write the formula because I'm just going to take out the charges. This time, I don't need brackets because the 2 only applies to this Cl, the symbol for chlorine. If there was another aspect to that symbol for chlorine, I might need brackets, but because Cl is a chemical symbol of chlorine on its own, the 2 does not, I don't need any brackets around it. And I don't need a number beside magnesium because there's only one of them and we don't show a 1 in the chemical formula. Example 3. Write the formula and the ionic formula for iron 3 bromide. Now the difference with this question here is the number in Roman numerals. The number in Roman numerals actually gives you a bit of a help because it tells you the charge without making you look at the periodic table. We're given a number in Roman numerals because this is a transition metal, iron is a transition metal, and therefore we can't tell the charge just by looking at the periodic table. The number in Roman numerals gives the charge, that's 3, so the charge on iron is 3+, so we've got Fe3+. The charge on bromide is 1- because it's in group 7, so for that one you can find out the charge just by looking at the periodic table. Now that I've got the charges on the ions, I need to work out how many of each I need. Iron's 3+, bromide is 1-. So hopefully you can tell just by looking at that we need 3 of our Br- to balance out the charge of the Fe3+. That's going to give us 3+ altogether, 3- altogether, and the charges will balance out as neutral. So just like in the example before, because there's only one of the irons, I'm just going to write it as it is, Fe3+. Because I need 3 of this whole thing, this Br-, I put that in brackets, and I put the 3 outside the brackets. The number goes to the bottom right because I'm showing how many of that thing there are in the formula. We have brackets because I have 3 Br and I have 3- charges. The 3 has to multiply the whole thing by 3. So that's the ionic formula. Once I've got the ionic formula, the chemical formula, nice and simple because I just need to take out the charges, and the chemical formula is FeBr3. So just like I said at the beginning, make sure you're aware that the ionic formula shows both the charges, 3+ and 1-, and the ratio. So the ratio is given by the fact that there's no number beside the iron, so we can assume that there's only one of these, but there's a 3 to the bottom right of the bromide. That tells us that we have iron and bromide ions in a 1:3 ratio. The chemical formula doesn't show these charges, it doesn't show 3+ and 1-, but it still shows that we have iron and bromide in this 1:3 ratio. Example 4. Write the ionic formula and the formula for magnesium hydroxide. So this one again is slightly different. Magnesium is one of our main group elements, so we should know that magnesium has a 2+ charge, it's in group 2. Hydroxide isn't an ion that you'll find on the periodic table, it's not an element, it's what we call a group ion, and it can be found on page 8 of the National 5 Chemistry Data Book. Once you've looked up your data book, you'll find that the hydroxide ion has the formula OH, 1-. So again, once we've got the charges of each ion and the formula, we need to just work out how many of each we need so that the overall charge balances out. Magnesium is 2+, our OH, our hydroxide is only 1-, so we need 2 of these hydroxides to make our charges balance out to be neutral overall. This is because our ionic compound has to be neutral overall. Once we've worked out how many of each type of ion we need, we can put them together in the ionic formula. Now, because I need 2 of this whole thing, I need to put brackets around the hydroxide. And the 2 goes to the bottom right of the formula to show that there are 2 of this whole thing. So that's my ionic formula, showing both the charges, we've got a 2 plus and a 1 minus, and the ratio of magnesium to hydroxide. So the ratio from this ionic formula is that we've got 1 magnesium, because there's no number to the bottom right, and we've got 2 hydroxides. So magnesium and hydroxide come in a 1:2 ratio in that compound. When I do my chemical formula, it's a little bit different this time. I've only got 1 magnesium, so that's fine. I just write magnesium, I don't need to put in the 1. But because I've got 2 hydroxides, even though I'm not going to show the charge, I still need to show that I've got 2 of this whole thing. So this time, in the chemical formula, I'm still going to put brackets around the hydroxide, and the 2 goes outside the brackets. That shows that we've got 2 of this whole thing. If I wrote my formula like this, that would suggest that we had only 1 oxygen and 2 hydrogens, whereas actually what we've got is 2 of this OH group, so this would be wrong. And from this chemical formula, again, we can see that we've got magnesium and hydroxide in a 1:2 ratio. The only difference between the chemical formula and the ionic formula is that the chemical formula does not show the charges.